Good day, students. Welcome to Mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 1 to 5 of the Geometry Common Core Regents exam for January 2016. If you have any questions as we go over this material, just feel free to post your questions in the comment section below, and we'll be glad to assist you at our earliest convenience. All right, let's take a look at question number 1. It reads, William is drawing pictures of cross-sections of the right circular cone below. Question, which drawing cannot be a cross-section of a cone? So we have a cone, the sketch of a cone presented here. And one thing I want you to remember is what a cross-section is, okay? Now, a cross-section is basically an outline that's formed when you intersect a plane with a solid. In this case, the solid that we're going to be intersecting a plane with is a cone, okay? So if we intersect a plane with this solid in different orientations, what kind of outlines will be created? That's what we're going to be trying to determine in this problem. All right, so on the actual Regents exam, you'd be expected to visualize the intersection of a plane and a solid. I'm going to be using the tool here from Algebra to help you visualize the different shapes that are formed when you intersect a plane with a cone, okay? I have two cones here, but we're just going to be focusing on one cone, namely the cone at the bottom. And then we'll see what shapes we can form here, okay? Now, as you can see, if I tilt this cone slightly, and we view it from the top, let's view this from the top. Now, what kind of shape do you see there? Look at it, that's kind of like an elliptical figure consistent with option number 4. Okay, so if you intersect the plane at an angle, if the plane intersects the cone at an angle, you end up with a conic section known as an ellipse. Okay, now what happens if we tilt it a little bit further, like that? What do we have? Tilt it a little bit more. Bam, you have a parabola. This shape is consistent with option number 3. Okay, so 4 and 3 are cross sections that can be formed. Now we have one more. Now what if I tilt it all the way? Okay, if I tilt it all the way up, just focus on the cone on the bottom. Do you see the cross section that's created, the outline of the intersection of the plane and the cone? You have like a triangular shape there, and that's option number 2. The only cross section that cannot be created by intersecting a plane with a cone is option 1. There is no way you can orient your plane in such a way that you get a square outline as the intersection. There's absolutely no way. You can either get this triangular shape, parabolic figure, an elliptical figure, but there's no way you can get a square. So our answer for question number 1 is option number 1. All right, now let's direct our attention to question number 2. All right, let's take a look at number 2. It says an equation of a line perpendicular to the line represented by the equation y equals -1/2 x minus 5 and passing through 6 -4 is. Now, one thing you want to note about perpendicular lines, or as follows, we know we have the word perpendicular here, is that if you have two lines that are perpendicular to each other, let's say M1 is the slope of the first line and M2 is the slope of the second line, then the product of these slopes is always going to be -1, or the slope of one line will be the negative reciprocal of the other, or the inverse of the other. Okay? All right, let's keep that in mind. Now, in order to write down the equation of a line, we need two things. We need a point and a slope. This is the equation that we're going to be using for this problem. So let's write it down. The equation is the point slope form of the equation of a line, y minus y1 equals mx minus x1. Okay? All right, so let's see what we have here. We need the slope and a point. So let's start out by finding the slope of the second line. Okay? So let's call this the first line. So let L1 be y equals -1/2 x minus 5. Okay? Now, if this is the equation of the first line, if I write down the slope-intercept form of the equation of a line, what does this tell us about the value of the slope, m1? The slope is always the coefficient of x. So m1, the slope, is going to be negative 1/2. Okay? Now, what is the slope of the second line if it is perpendicular to the first line? So that's the question. So if L2, second line, is perpendicular to L1, all right, then M2, the slope of the second line, is going to be the negative reciprocal of the slope of the first line. Okay, correct that real quick. So let me erase that. This negative reciprocal of the slope of the first line. Okay. All right, so let's determine what the slope of the second line is. All we just do is reciprocate the slope of the first line, m1, and take the opposite of that. Okay, so m2 is going to be the negative reciprocal. What is the reciprocal of negative 1/2? The reciprocal of negative 1/2 is negative 2/1. Remember, when you reciprocate a number, nothing happens to the sign, okay? And when you multiply it across, slash and dash, you end up with positive 2, so that's the slope of the second line. Now, in order for you to write down the equation of a line, you need a slope and a point. It was indicated to us earlier that the second line passes through 6, 4. Okay, so the point that we're looking for is 6, comma, negative 4. And the points in the form of the equation of a line, this is x1, and this is y1, and this value right here is m. All right, so all we're going to do is plug in the values into that equation. So let me rewrite the equation here so we don't get lost as I make this substitution. Okay, y minus y1, mx minus x1. So if we substitute, we're going to have y minus y1, which is negative 4. Now, anytime you're substituting a negative value into a formula or an equation, you always want to make use of parentheses so you don't make sign errors, okay? Slope is 2, x minus x1 is 6. Now, if you look at the options that we have, they are all in slope-intercept form. Y has been solved explicitly for. So in order for us to match this equation with the correct answer, we have to get y isolated. Okay, so all you're doing is just transforming this equation from point slope form into slope intercept form. All right, so minus times minus is plus. Anytime you multiply the same signs, you always end up with a plus. Y plus 4 equals. Now we're going to distribute this 2. Remember to distribute to both terms in the parentheses. Okay, so you're going to have 2x minus 12. To finish it up, we'll simply subtract 4 from both sides. So let's do that. Minus 4, minus 4. Remember, the goal again is to get y isolated. Okay? Well, carry out that subtraction. Let me put a line here so we can clearly see what the final result is. We're going to end up with y equals 2x, same sign, add and keep the sign, minus 16. Option number 4 is the correct answer for this problem. Okay? All right, let's take a look at problem 3. It says in parallelogram QRST shown below, diagonal TR is drawn. U and V are points on TS and QR respectively, and segment UV intersects TR at W. All this information is highlighted in this figure. If measure of angle S is 60 degrees, measure of angle SRT is 83 degrees, and measure of angle TWU is 35 degrees, what is the measure of angle WVQ? Okay, all right, so to get started, just a real quick collection of theorems I would like you to keep in mind as we solve this problem. First of all, you want to remember that vertical angles are congruent, okay? So in this figure we have right here, this is a parallelogram, this line. This side is parallel to this side, and this side right here is parallel to that side. So Vertical angles, for example, these are vertical angles. They're congruent. Okay. Another thing you want to keep in mind is that same-side interior angles of parallelograms are supplementary. So this angle plus this angle add up to 180 degrees. That's what supplementary means. Okay. This angle right here plus this angle right here adds up to 180 degrees. So same-side interior angles are, or you can think about it as adjacent angles are supplementary. Okay. And then the exterior angle is equal to the sum of interior angles. This has to do with triangles. All right, so let me just rephrase that. So the exterior angle of a triangle is equal to the sum of interior opposite angles. So let me illustrate that for you in this diagram here real quick. So if you take a look at this triangle right here, WBR, this is an exterior angle right here. Guess what? This angle is equal to the sum of the interior opposite angles. So this angle plus this angle right here, they basically add up to give you this angle. Okay? So that's the exterior angles theorem. So we're going to be making use of these three theorems in solving this problem. Okay? All right, so what I'm going to do, I'm just going to make a bigger figure, and I'm going to use numbers to represent my angular measures so I don't write too much, okay? All right, so let's call this angle right here SW SRQ. Let's call this angle 1. Okay, so this is angle 1. And then in this triangle right here, angle VRW, let's call that angle 2. So this one right here, let's call this 2. And let's call this angle right here, let's call that angle 3. Angle 3. And WVR, we're going to call that angle 4. Let's call angle 5 this exterior angle right here, WVQ. See, that's what we're looking for. Angle 5 right here. So this is angle 5. And then we're provided with TWU. Let's call that angle 6. Okay. And then what other information did we have? Oh, we were given angle S, so let's call that 7. All right. Okay, so the reason again I'm representing my angles with numbers is I want to make it easy to write, so I don't keep writing too many symbols. That takes a lot of time. Okay. All right, so let's go ahead and get started with this. Now let's go ahead. Let's put in the value of the angles in the figures that we have. Okay. So as indicated earlier, measure of angle S. Angle S in this case, I'm going to call it angle 7. So measure of angle 7 is 60 degrees. That's a given. Okay. What else? Measure of angle SRT. Measure of angle SRT. Well, let's give that a name. Let's call this SRT. Let's call this angle 8. Okay. So measure of angle SRT is also my measure of angle 8, which I'll be using in this problem. That's 83 degrees. What else do we know? We know that the measure of angle TWU, as indicated earlier, measure of angle TWU is the same as measure of angle 6. That's what I'm going to be using. So that's, let's see, what is it? 35 degrees. Okay. And the goal is to find the measure of angle WVQ or angle 5. Okay, so I want to find the measure of angle WVQ, which is basically the measure of angle 5. All right, so first thing we're going to do is see how I can work my way into this triangle right here. This triangle is my target area. Okay, so I've been provided with information on the outside. So this is 60 degrees. I've been provided with that. I've been provided with this. This is what, 35. And I've been provided with this one right here, which is 83. Now I want to work my way in, okay? Now with these two angles right here, angle 1 and angle 7, what are they? Angle 1 and 7 are adjacent angles of a parallelogram. Okay, think about it as two parallel lines on a transversal. They're like same side interior angles. These two angles are supplementary. Okay, so let's go ahead and write that down. So measure of angle 1 plus measure of angle 7 is equal to 180 degrees. Okay, so basically adjacent angles of a parallelogram. Adjacent angles of a parallelogram are supplementary. Okay, so guess what? I know what 7 is, so I can use it to find 1 since they add up to 180. So the measure of angle 1 plus 60 is equal to 180. All right, that's just by substitution. Now to get the measure of angle 1, I'll simply subtract 60 from both sides. And I'm left with the measure of angle 1, which is 120 degrees. Okay, now we're getting close. So this entire angle right here is 120 degrees. Now, can I find out what the measure of angle 2 is using angle 1 and 8? Absolutely. The measure of angle 1, or let's put it this way, measure of angle 2 plus measure of angle 8. These two angles add up to give you measure of angle 1. Okay, these are a pair, they add up to measure of angle 1. Okay, so this is using the by angle addition. Okay, angle addition. Now we can find out what measure of angle 2 is because we know what 8 and 1 are. So measure of angle 2 is, measure of angle 8 is 83 degrees. Equals measure of angle 1, which is 120 degrees. So what I'm going to do is subtract 83 degrees from both sides so we can figure out what measure of angle 2 is. Okay, subtract 83, subtract 83. And then we have measure of angle 2 equals 120 minus 83 is 37 degrees. Okay, so this angle right here is 37 degrees. Let me divvy up my workspace. Okay, now I'm getting I found one component of this triangle right here, which I can ultimately use to find angle 5, so that's good. Measure of angle 2 is 37. Now, can I figure out what the measure of angle 3 is? It's related to angle 6. What is the relationship between angle 3 and 6? They are vertical angles. What do we know about vertical angles? They are congruent. Okay, so measure of angle 3 is equal to measure of angle 6 because they are vertical angles. All right, so since angle 6 is 35 degrees, guess what? Measure of angle 3 is simply 35 degrees. Okay, so this is 35, this is 37. Now we can use the exterior angles theorem to find out angle 5. What is the relationship between 3, 2, and 5? The sum at the exterior angle is equal to the sum of the interior opposite angles. Okay, so measure of angle 5 is equal to measure of angle 3 plus measure of angle 2. Now, if you do not want to use the exterior angles theorem, that's fine. All you simply do is you add these two, subtract from 180 to get 4. 4 is a linear pair with 5, so just subtract 4 from 180, that gives you 5. Okay, so whichever way you like, you can do. All right, so measure of angle 5 is measure of angle 3, which is 35, plus measure of angle 2, which is 37. If you add these two angles together, you end up with 72 degrees. Our answer for number 3 is option number 3. All right, let's take a look at question 4. It says a fish tank is in the shape of a rectangular prism. A fish tank in the shape of a rectangular prism has dimensions 14 inches, 16 inches, and 10 inches. The tank contains 1,680 cubic inches of water. What percent of the fish tank is empty? Now, one thing you want to remember is that the part of a whole in percentage form can simply be achieved by dividing the part by the whole and multiplying it by 100. Okay, so what we're going to do here, anytime you're working with some kind of geometric solid that's presented in text format, you want to give yourself a visual so you can accurately label the dimensions and write down the correct formulas, okay? So I'm going to go ahead and sketch a rectangular prism. We'll put in the measurements and then calculate the percent of the tank that's empty. Okay, so this is just a sketch of our rectangular prism here. So we have water in it, and let's say this is the water right here, occupying part of the volume of the tank. So that goes to the top of the water, and then it's all over here. Okay, so this is the part that's the volume of the water is 1,680. Okay, and guess what? This portion right here, this volume, this is where it's empty. That's what we want to find in percentage form. All right, let's put in the dimensions of our rectangular prism. So it's not drawn to scale, so pardon me, this is 1614, and the height is 10. Okay, so let's go ahead and write down some equations. What is the volume of the empty portion of the tank? Volume of empty is simply the volume of tank, take away the water volume. Okay, so this is basically the portion that's filled. It's filled with water. So if we take the entire volume of the tank and subtract the water volume, then we'll be left with the volume that's empty. All right, so let's go ahead and figure out what we do not know. We know that the volume of water is what? The volume of the water is 1,680 cubic, what was the unit? Cubic inches. Now, let's find out the volume of the tank, okay? In order for us to find the volume of the tank, we need to remember the following formula for the volume of a prism, okay? So volume of prism, rectangular prism is area of the base times the perpendicular height, okay? All right, or you can think about it as the area of the base is length times width times the perpendicular height, big H. Okay, so let's populate our measures. So this will be our width, this is our length, and this will be our big H right here. So what is the volume of the tank? We just simply put in the measures, okay? So volume of tank is going to be length times width times height, which is, let's put big H here. Length times width times height is what? Length times width times height is 16 times 14 times 10. All right, and when you carry out the calculations with your calculator, you end up with 2,240 cubic inches. Now, what is the volume of the empty portion of the tank? Scroll up a little bit. So, volume of the empty portion of the tank is simply the volume of the entire tank minus the volume of water. Okay, so volume of empty is volume of the entire tank, 2,240 cubic inches, minus the volume of the occupied portion of the tank, the volume of the water, 1680. Answer, if you subtract these two, you get 560. Okay. Now, what is this, or what percent of the entire tank is this volume? In order to do that, let's go back to our formula. It says part of the whole in percentage is basically the part divided by the whole times 100, okay? So the part of the whole that we're looking for here is the volume, is the empty volume, okay? So let's go ahead and write that down. So percent of volume empty is simply going to be volume empty divided by total volume. So this is part empty. This is whole, the entire volume. This will give us the answer in decimal form, but we have to multiply by 100. to convert it into percent. Okay, so if we do that, we're going to have 560, the volume that's empty, divided by the entire volume, 2,240. Multiply that by 100. And when you carry out your calculations, just use a calculator, you end up with 25%. Okay, so that's the percentage of the tank that's empty. Answer is option number 2. Okay, let's take a look at question number 5, the last in this review installment. It says, which transformation will result in the perimeter of a triangle being different from the perimeter of its image? Okay, so let's see here. One thing you want to remember is your transformation formulas. So we have 4 of them listed here. The transformation that involves switching the x and y axis is a line reflection along the line y equals x. The one that negates, the transformation that negates the y coordinate values is a line reflection along the x-axis. If you negate the x coordinate, that'll be along the y axis, okay? The transformation that involves multiplying the coordinates by a number, that's a dilation by the factor of the number that you're multiplying the coordinates by. And lastly, when you add or subtract numbers from the coordinates, that's a shift, okay? The directional shifts is dependent on the magnitude of the number you're adding or subtracting from each coordinate. Now, one thing you want to keep in mind are the 2 types of transformations we have. We have isometries. Basically, these are translations and rotations, and then you have dilations. Okay? Now, those are not isometric transformation. Okay? So what are isometric transformation? Iso basically means the same, and metry means measure. Okay? So anytime you have isometric transformations like reflection, let me show you right here. So this one, 1, 2, and 4, reflection, reflection, and this can be thought of as a translation. These are isometries. Okay? What does that mean? It simply means that after you carry out the transformation, the dimension remains unchanged. Okay, so if the dimension, the length and the width, the height, the depth, if those remain unchanged, guess what? The measures or the calculations dependent on those measures remain unchanged also. So the perimeter, for example, the area and the volume under isometric transformations remain unchanged. However, when you have a dilation, guess what? You're changing the dimensions. So the perimeter, the area, and the volume also change. So what this question is asking in essence is which of these is not an isometry? Which of this is a dilation? Because dilation causes an alteration in the measures so that the measures dependent on on the dimensions of the sides change. Okay, so to answer this question, let's look at these 4 transformations we have here and let's classify them as reflections, translations, rotations, dilations, and if they're isometric or not. Option 1, this one right here is a line reflection along y equals x. So this is a line reflection. Is it isometric? Yes, it is isometric because you're just reflecting along the line. You're not changing anything, okay? Number 2, in this transformation, you're just changing the signs of the y coordinates. This is a reflection about the y-axis. I'm sorry, the x-axis as indicated in Formula 2. This is a reflection, is a line reflection. Okay? And guess what? Line reflections, even point reflections, are isometric. This is isometric also. Just like option 1. Check. Number 3, xy involves multiplying or scaling the coordinates by a factor of 4. This is a dilation. And guess what? It is not isometric. If it's not isometric, that means the dimensions are changing, hence the perimeter of the shape of the triangle will change. Okay, so this is the answer we're looking for. This is the one that would result, remember the question asked for which transformations would result in the perimeter being different. So there's a change in perimeter, okay? So the answer is option number 3. Let's just take a look at 4. for is a shift or translation. Okay, when you just translate an object or just move it across a coordinate system, you do not change the dimensions. Okay, this is also an isometry. So this one doesn't change the perimeter or the area of the triangle. Okay, so the answer is clearly option number 3. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe for the remainder of this review series. If you have any questions or comments concerning the contents of this tutorial or any geometry common core related question, just ask your question below. Remember, our goal is to try our best to help you pass the upcoming exam, okay? More clips can be found on Mathgotserved.com under test prep. Thanks again for watching and have a wonderful day.